my video math. For this first lesson, I will be showing how to do a definition of a derivative. So say for instance, we're given the problem, a limit as delta x approaches 0 of 2e the x plus delta x minus 4x plus delta x plus 11 minus 2e to the x minus 4x plus 11 all over delta x. Now this may look very intimidating, but in fact these problems are just writing out a sentence. So for this, what represents the derivative? So first you have to find out what is the derivative. So you know that in the end, this is going to end up being the derivative. This 2e to the x minus 4x plus 11, because it's what would end up if all of these were multiplied together and taken the derivative. So your sentence is going to be, this limit represents the derivative of 2e to the x minus 4x minus 11, plus 11, excuse me. Next up, I will be doing an example of a derivative shortcut. So rather than doing everything full out and solving, we can just make it a lot easier. So for instance, take the problem when y equals 4t squared plus 2t plus 12. Now this derivative shortcut, you take the exponent and you multiply it by your coefficient. So in this case, 8, you leave the t, and now you're going to subtract 1 from your exponent, so it's just 8t. For the next one, this is the imaginary t to the first. So multiply, subtract 1, so your t is gone. And this one, you have a t to the 0. 0 multiplied by 12, it totally disappears. So y prime is equal to 8t plus 2. Next up, I'm going to show you how to do an antiderivative. So an antiderivative is the opposite of a derivative. It's also known as an integral. So when taking a derivative, you end up with a y prime. When taking an antiderivative, you go from this y prime back to just your normal y equals. So it's undoing what the original derivative did. So let's do an example. Say for instance you're given the integral of 7x in respects to dx. So you just remember antiderivative. AD. Add, divide. So you'll look at your exponent, which this x has the imaginary 1. You'll add 1, so this is going to become an x squared, and then you'll divide that exponent from your coefficient. So this derivative, this integral, antiderivative, will become 7/2 x squared. But this is an indefinite integral, because there's always this imaginary unknown number on the end. Now eventually you'll learn how to solve for this, but I'm not showing you how to do that yet. So instead you'll just place a constant c on the end of your formula. So let's try another one. Say taking the integral of 2 cosine x in respects to dx. So add, divide. This again has the 1. So add 1 becomes x squared. Divide 2 by your coefficient, and that will just become 1. And in this case, the integral of cosine is a negative sign, which is just something you have to memorize. And then you add your constant plus c, and that's your integral. Next up, I'm going to be showing you how to solve for asymptotes analytically. So in a graph, you could have asymptotes vertically, horizontally, or slanted. But from one equation, you can't have a horizontal or a slant in the same graph. It can only be one or the other. So for instance, say we're given the equation j of x equals x cubed, plus 4x squared all over x squared minus x minus 2. So first off, let's just go ahead and look at the equation. We know that there has to be a slant asymptote for this one because the exponent on the top is larger than the exponent on the bottom. So to solve for a slant asymptote, you use long division. So the top divided by the bottom. So to get this x squared into this x cubed, you'll multiply by x and get an x cubed. If you multiply this x by an x, you get a negative x squared. And you leave the 2. Now subtract, this cancels out. Since you're subtracting a negative, they both become positive. So it becomes a 5x squared minus 2. And now to get this 5, this x squared to get this 5, you add 5. So that will become 5x squared minus 2. Subtract, this cancels out. And this is just your leftover. So here is your equation. And you know that you'll have an equation for a slant asymptote because it's not just an x equals or a y equals, it's a linear line. So your slant is equal to y equals x plus 5. Now let's go ahead and try and find our vertical asymptote, since we know there can't be a horizontal because there's a slant. So to find the vertical, you have to factor first. So factor the bottom, and you get x plus 2 and x plus 1. And on the top, pull out an x squared, and you end up with x plus 4. Now nothing cancels out, so you know there's no removable asymptotes, and you know they're that because when they cancel out, they are removed. So to solve for your vertical asymptotes, you set this bottom to 0 because it's whatever makes that point impossible. So if you divide by 0, that's not possible. So when x equals negative 2 or negative 1. And those are your vertical asymptotes. So for this graph, you'll end up with 3. 1 slant and 2 vertical. This week, I'll be doing an example of u substitution for integrals. So this is just like u sub, just in this case, you're taking an integral rather than a derivative. So for our example, integral of x squared minus 5 squared times 2x dx. So in this case, our u is equal to x squared minus 5. So our du is 2x. So what we're left with is the integral of u squared times 2x. So since these two are the same, we're going to go ahead and cancel out and just become 1. So it's the integral of 1 times u squared dx. So now let's take the integral. So it's an antiderivative, so add and then divide. So add, so this is going to become u cubed, and then divide, so it's 1/3 u cubed plus c. So now let's plug u back in. So it's 1/3 x squared minus 5 cubed plus c. And that's your integral. I will be doing an example of the chain rule. The chain rule is used to take derivatives. For instance, the equation y equals 6x squared minus 5 to the 7th. So this is just like using u sub. U is 6x squared minus 5. So the du is 6x. So it's y equals u to the 7th. So this coefficient is 1, and this one is 6x, so to make them the same, divide by 6, so this becomes 1/6. And now take the derivative. Multiply down, 7/6, and subtract 1. And now you plug your u back in. So y prime is equal to 7/6, 6x squared minus 5 to the 6th. And that's your derivative. Now you know what your u is by whatever is in the parentheses, most often. For this entry, I will be giving an example of using the product rule. The product rule is used to take a derivative of two things that are multiplied together. For instance, x of t is equal to t times the natural log of t plus sine 7 minus 2t. So here is where we'll be using the product rule because it's two things multiplied together. So the product rule is first times derivative of the second plus second times derivative of the first. So first, t, times derivative of natural log of t, which is 1 over t, plus second times derivative of the first t, which is 1. And then you have to take the derivative of this section separately, which in order to do that you have to use u sub. So our u here is 7 minus 2t. So that would make our du negative 2. So the derivative of sine is cosine. And since it's a negative 2, it's going to become a negative cosine. 7 minus 2t, and then times your du. And now you're going to go ahead and put it all together. So that would mean x prime of t is equal to 1 plus ln of t minus 2 cosine 7 minus 2t. And that's your derivative. This time I will be doing an example of quotient rule, which is a lot like the product rule, but in this case you're taking the derivative of two things that are being divided by each other. For instance, with the problem g of theta equals theta over 1 plus cosine theta. So the quotient rule is bottom times derivative of the top minus top times derivative of the bottom, all divided by bottom squared. So for this one, it's bottom times derivative of the top, which is 1, minus top times derivative of the bottom, which in this case is negative sine theta. Because if you take a u sub, your u is 1 plus cosine theta, and your du, 1 just becomes 0, and then the derivative of cosine is negative sine. All divided by bottom squared. So now, once you can put it all together, it will become 1 plus cosine theta minus theta sine theta plus theta sine theta, excuse me, so you have two negatives, all over 1 plus cosine theta squared equals g prime of theta. And that is your derivative. Next, I want to do an example of finding the carrying capacity in a logistic function. So for instance, with the equation dp over dt is equal to 5p minus 0.002p squared. To find the carrying capacity, or the limit, as x approaches infinity of p of t, first, let's go ahead and turn this into a fraction. So 5p minus 1/500 p squared. Now let's go ahead and put these together and set them equal to 0. So 0 equals 2500 p minus p squared. Now something that they both have in common, we can go ahead and factor out p. 0 equals p, 2500 minus p. Now we conveniently have in the carrying capacity equation, which is p L minus p. L being your carrying capacity. So that would make our carrying capacity here, the limit as x approaches infinity of p of t is equal to 2500. So really, all that you're trying to do is get it to look like this. And then you'll know exactly which one is your carrying capacity. For the final entry, I will be doing a problem using partial fractions. So partial fractions is used to take an integral. For instance, take the integral of 1 over x squared minus 6x plus 8. So for this problem, you have to factor it first. Now, I'm sure we can agree that this fraction is the same thing as doing this. Because they have the same numerator. So for partial fractions, we'll change these two numerators to an a and a b. Now you're going to cross multiply. Now you need to set them equal to 1 in this case, because that's what the numerator was at the beginning. And then you solve for x. So if x were equal to 2, then this would become 0. You'd solve for this part. So b would equal 1/2. And then if x is equal to 4, this part would become 0, and a would be equal to negative 1/2. Now we plug it back into the original fractions that you factored out. So negative 1/2 as a over x minus 4 plus 1/2 for b over x minus 2. And now here, you'll take the logarithm. So negative 1/2 is equal to the natural log of x minus 4 plus 1/2 natural log x minus 2. And that is your integral. Next, I'm going to do an example of the first derivative test. So the first derivative of a function is finding the slope. So using the first derivative test, you're going to be finding relative extrema, which is the minimum or the maximums of the graph, just from the equation itself. So with the function f of x equals x squared minus 6x, we'll start out by just taking the derivative. So f prime of x equals 2x minus 6. Now we're going to factor and set it equal to 0. So we can pull out a 2. 2x minus 3 equals 0. And now solve for x. So x is equal to 3. So we know that this is one of your critical numbers. So this is possibly an extrema, so this is possibly an extrema. So now, in order to find out if it's a minimum or a maximum, we're going to put it on a number line. So since that's our only critical number, that's the only one on our line. So now let's take a number less than 3 and plug it into this factored form. So let's say 0. So if you plug 0 in, you're going to get a negative number. 0 minus 3 is negative 3, times 2 is negative 6. So we'll put a little negative there. And then a number that's above 3, say 10. So 10 minus 3 is 7, times 2 is 14. That's positive. So now look here, and you see that the sign changes. That means it's an extrema. And since it's going from a negative slope to a positive slope, it's a minimum. So at x equals 3 is a minimum. And you have to make sure you justify everything. So it's because the sign changes. In this case, from a negative to a positive. Now, in this case, you know that there aren't any maximums because there's only one critical number. But say there were, then you would also write x equals 4, for instance, is a maximum because the sign changes from positive to negative. Because the slope would go from a positive slope to a negative slope. So next up is an example of the second derivative test. So we learned before that the first derivative means the slope of a graph. Now with the second derivative, it tells you the concavity, so if it's concave up or down. So for instance, take the function f of x equals 2x cubed minus 3x squared minus 12x plus 8. So first you have to take the first derivative, so f prime of x equals 6x squared minus 6x minus 12. Factor and equal to 0, just like the first derivative test before. So let's pull out a 6. 6x squared minus x minus 2, all equal to 0. Factor it out. X minus 2 and x plus 1. So now our x's are equal to 2 and negative 1. So we know again that just like before with the first derivative test, these are critical numbers. So these are maximums or minimums. So first, now we do the number line again, just like in the first derivative test. Negative 1 and 2. Let's pick a number less than negative 1, say negative 10. Plug it into here. It'll become a negative times a negative is a positive. There's our positive. Now a number in between, say 0. Plug it in, it's a negative times a positive. That's a negative. A number above, larger than 2, that's 10. It will become a positive times positive, which is a positive. So now both of these are minimum and maximum. So the negative 1 is a maximum because it's changing from positive to negative. So when x equals negative 1 is a max. because f prime of x changes from positive to negative. And then when x equals 2 is a minimum because f prime of x changes from negative to positive. So this is just another example of your first derivative. But now once you have this answer, you want to find the point of inflection as well as just your relative extrema. So you have to use the second derivative. So you take the derivative again of what you factored out. So f double prime of x is equal to 12x minus 6. When you factor it out, 6, 2x minus 1, equal it to 0, x equals 1/2. Now again, put it on its own special little number line, and you're going to end up, if you put a number less than 1/2, say 0, you end up with a negative, because a negative times a positive. If it's above 1/2, say 10, end up with a positive. So your sign changes, so you know it's a point of inflection. So again, you write, when x equals 1/2 is a point of inflection because f double prime of x changes signs. So this part is your answer, and all of this.